crosses the x-axis. So I'm going to hit y equals, get rid of this, x squared I'll do a zoom 6, standard zoom, and just see where it crosses the x-axis. I'll also get some other points, just so I can create a reasonable graph out of this. All right, to do that, we hit second, graph, and we organize the table so that it's symmetric in the y column, 0 on the top, 0 on the bottom, -5, and so on. That's the table of values. We plot those points. Not 2, 0. Draw a curve through those points best you can. Really can't do much better than that, personally.
Can you just repeat that? What do we put in the graph again to get that? What was it?
So you're going to hit y equals,
Yep.
type in the equation, then zoom 6 to look at the picture, then second graph to get the table. All right. Apparently I could do a little bit better. So this is the picture. The solutions, as they say, would be x is equal to -4 and +2, or +2. Now, algebraically, you can do it by factoring, completing the square, quadratic formula. Well, not quadratic formula, because that's a numerical approach. But factoring or completing the square would be appropriate to solve algebraically. So, first thing you should try to do is to solve by factoring x and x. You know, you're looking for values that are going to multiply to -8, but also add to a +2. You know, looking at possibilities, 1 and 8, 2 and 4. You look at the one that makes the most sense. 2 and 4, the numbers 2 and 4 are separated by 2 units. So that seems to make the most sense. So I put a 4 and a 2 here. To make a negative product, they'd have to have different signs. In order for that sum to be positive, the larger number should be positive. Quick double check. Got a -2 on the outside, +4 on the inside. Result is a 2. So we have our factors. So now I'm going to set each of my factors equal to 0 using the zero product property. And get my results, -4, +2. Which, honestly, I mean, you wouldn't know this going in, but it makes sense because this is the equation that gives that graph, right? They're the same problem. I'll take it as a typo, though, because for the first one, it really should be 0 equals instead of y equals. Solve the quadratic 0 equals x squared plus 2x minus 8 graphically. But we do that by graphing y equals x squared plus 2x minus 8. Now, when it comes to actually creating the graph, we did this in the last part of the unit, but we also did it in the project. Writing the equation is very doable if you know the vertex and the y-intercept. But it's much easier if you know the x-intercepts. All right? So we have an x-intercept here at x equals 3. An x-intercept here at x equals -1. We could use that information basically following this process, but in reverse. We can come up with the equation. Well, or at least the equation that led to those roots. All right, so if I start off with x equals -1 and x equals 3, I have my vertex here at 1, -4. Kind of hang on to that for a second. I could take my roots, x equals -1, and kind of work backwards. So instead of solving for x, I'll unsolve for x. It's like, what on earth does that mean? It just means get 0 alone on one side of the equation. So I'm going to add 1 to both sides. Subtract 3 for both sides. X plus 1 equals 0. X minus 3 equals 0. So when solving a quadratic, we apply the zero product property. I want to undo that. All right. So what happened before it became these two equations was that it was a pair of factors, x plus 1, x minus 3 equal to 0. Then I would distribute it out. All right. So x squared minus 3x plus 1x minus 3 equals 0. X squared minus 2x minus 3 equals 0. This tickle in my throat, I just want to cough drop it up. So I have an equation that would give me this graph. It's just a question of whether or not it has the right shape. If it does, then I'm in good shape. But if it doesn't, then I got a problem. All right? But we'll handle that problem in a minute. So I'm going to take a look at the picture. We're going to call this f of x is equal to x squared minus 2x minus 3. You could do it by looking at the graph, but you could also do it by the table. Let me look at the graph first, zoom 6. And just make sure that it has the same vertex, that same turning point. All right, right here, is this at 1, -4? Kind of looks like it, but let's confirm. Second graph. At the x value of 1, we have a y value of -4. All right, so we're in good shape here. All right. If it didn't, you would need a minor additional step. There's two ways to handle it. One is algebraic in the sense that, you know, if you remember from the project, it wasn't the easiest thing in the world to do, right? But if you use your vertex equation, you can solve for the a value, the appropriate a value. The issue is that that's time consuming. Instead, what I do is I look at the 1 unit slope. All right, the 1 unit slope is the slope that you would get if you went 1 unit to the right. I'm sorry. 1 unit to the right from the vertex. You just do a quick rise over run. Run. I always want to put an E at the end of every word. I don't know why. All right, you do a quick rise over run, and that would give you the multiplier for the equation. All right. So the rise over run here, the slope, is 1 over 1, which is 1, which means that I should multiply my equation by 1. Every term by 1, which means I'm not really changing anything. So if your 1 unit slope is 1, then you've already done the necessary algebra to get the work done. Right? So that happens again, well, almost. In the second example, that 1 unit slope is 1, but it's in the negative direction. All right, so down 1, right 1. So the 1 unit slope is equal to -1. So that's my multiplier for the equation, but I'll hold off on that because I have to address the roots first. X equals -2, x equals +2. Add 2 to both sides. Subtract 2 from both sides. X plus 2 equals 0. X minus 2 is equal to 0. Undo the zero product property. X plus 2, x minus 2. You get x squared. The outer and inner terms are going to cancel out. So I'm going to get x squared minus 4 equal to 0. All right. So at this point, what I would do is multiply both sides of the equation by a -1. So I'll get -x squared plus 4 equals 0. I'm multiplying by a -1 because that's my 1 unit slope. All right. We always multiply by the 1 unit slope. It was irrelevant in the last example because the 1 unit slope was equal to 1. Multiplying by 1 doesn't change anything. All right, but here it reverses the sign of each term, and we're left with f of x is equal to -x squared plus 4. All right, quick check. So this is my equation. Quick graph, zoom 6. It looks similar, but I want to be sure. So second graph brings me to the table. I'll line it up so that there's symmetry in the y column, the y1 in this case, and just check the points. 0, 4 is my turning point, correct. 1, 3, also correct. 2, 0, yep. -1, 3, yep. -2, 0, yep. Yeah, there's some other points, but those are irrelevant because they come off, they fall off the graph. All right. So that's the strategy there. Yeah.
So what was the significance of finding the slope, the -1, for example?
It gives you the multiplier for the equation. Because if I didn't multiply by -1, this is what I would have gotten. So I would have got this graph, which doesn't look anything like what we had on paper. By multiplying by the -1, it gives the direction of the parabola initially. All right, starting at the vertex, which is the most important point, it tells us where that parabola is going 1 unit to its right. So if it's going up, then you know it's an upward facing parabola. If it's going down, well, downward facing parabola. But in what way is it going down? Is it going down in a ordinary fashion, or is it very steep, or is it very wide? We don't know that until we come up with a 1 unit slope.
Thank you.
No problem. All right, so 3 and 4 are very similar. So let's hop to, excuse me, to number 5. It says write the quadratic equation given the zeros and whether the vertex is a maximum or a minimum. All right. Doesn't talk anything about the shape of the graph. It just tells us that these are the important values. The zeros, just to refresh your memories, zeros, another word for roots. My pen. There we go. All right. So it's telling us that x is equal to -3, x is equal to 4, and the vertex is a minimum, which means it's an upward facing parabola. Doesn't tell us anything about the shape, right? So all I need to know here is that my leading coefficient must be positive. All right. So the a value is greater than 0. It really doesn't matter what it is. I could use whatever multiplier I want, or maybe I don't multiply it at all. As long as that a value is positive, then I'm looking at a correct function. All right, and so x is equal to -3, which means x plus 3 is equal to 0. X minus 4 is equal to 0. X plus 3 times x minus 4 also equal to 0. So we get x squared minus x minus 12 is equal to 0. I need to make sure that my a value is positive. The a value is equal to 1, so definitely positive. So I can call this my final answer.
How did you know it has to be positive?
Because the vertex is a minimum, which means it must be an upward facing parabola, which puts the vertex at the minimum. All right. If it's an upward facing parabola, then the 1 unit slope is going to be positive.
Thank you.
All right. For number 6, and this is the last one we'll do together, I'll give you some time to practice. So we have just a 7, all right? And the vertex is at a maximum, opening downward. This tells us, well, a couple of things. One, it's only going to cross the x-axis at one point, right? Otherwise, we'd have more than one root. And that point must be the maximum of the parabola, all right? Parabolas have a maximum vertex value only when the a value is negative. All right, so I need to do a correction here. All right, but if I know my roots, you can kind of think of it both ways. Is x is equal to 7? I would write that twice because this is a double root. All right, we don't just have x is equal to one number. What happened was x was equal to one number twice, but since it was the same number, we only represent it once. Where does this graph cross the x-axis? 7 and 7. Well, couldn't you just say 7? Yeah, that's why we just say 7. All right, but what led to that? Two factors that were identical. So we get x minus 7 times x minus 7 equal to 0. Distribute it out. But then because the a value has to be negative, I need to multiply this equation by a negative number. Could be whatever negative number I want. Negative 407. You're right. Negative pi. Sure. Negative 1. That would be the simplest case. Right? Pick whatever number you want as long as it's negative. My recommendation would be to choose the simplest negative number, which would be negative 1. But if you chose to multiply it by negative 3,705, you would also be right. All right? So just keep that in mind. You multiply it by whatever you want as long as it's negative, and you're absolutely correct. Negative x squared plus 14x. Hey, you can just throw it on the back table. I'll get it. Thanks, Mark. So f of x would be equal to negative x squared plus 14x minus 49. And that would be my function. But like I said, I can take that expression, the x squared minus 14x, and multiply it by, plus 49, multiply it by whatever I want. So we multiply by negative 1. Do a quick zoom 6. 1, 2, 3, 4, 5, 6, 7. Right at x equals 7, it has an x-intercept. Also a vertex, as it turns out. If you're going to have a parabola that touches the x-axis only once, the location that it will touch the x-axis at or in would be the vertex. All right, but let's say I wanted to use negative 17. Okay, negative 71. Like I said, doesn't matter what what multiplier I use as long as it's negative. So very skinny parabola, but still intersects at x is equal to 7. All right, and it only intersects once. Very skinny. Doesn't look very parabolic, but that's because this archaic device uses square pixels that are actually fairly large. So things that are curved will come out if you zoom in enough. They'll always look linear. All right, it's a drawback to the calculator. All right, but that's the idea. Pick whatever you want. Maybe just a negative 7. Same deal. Intersects only once at x is equal to 7, but the shape of the graph is different. All right, it's skinnier. If I wanted to use a fraction, negative 0.01. It doesn't even show the entire parabola because most of it is happening, well, the other half of it is happening off screen, but it's a very wide curve coming into the x-intercept of x is equal to 7, and then it comes out of that. But it's indistinguishable from the x-axis until it gets past the x value of 10. All right, so you could play around. You use whatever multiplier you want as long as it's negative. All right. Telling us in which direction a parabola is opening indirectly. They tell us that the roots are x is equal to 0, x is equal to 5, and it has a minimum vertex. All right, minimum vertex means the parabola opens upwards. All right, so when I go to solve this, or at least get it into the general form of a quadratic, I need to get it into factor form first. All right, so nothing much I can do about the x equals 0, but the x equals 5 is preceded by x minus 5 is equal to 0. As you know, in the instance where we were solving a quadratic, what would you do? You take your factors, set it equal to 0, and solve. So unsolve, and then untake your factors and set them equal to 0. So my two factors here are x and x minus 5. Those would be multiplied and set equal to 0. All right. Now, in the instance where you don't have a graph, there's no way to compute the 1 unit slope. All right. So what we do is if the parabola opens upwards, we assume the 1 unit slope is equal to 1. If the parabola opens downward, as in there's a maximum vertex or turning point, we assume the 1 unit slope is equal to negative 1. All right. So that's telling me to multiply both sides of this equation by a 1 for number 7. It's not going to change anything. So you have two choices. One, you show the multiplication. Or two, don't. Very simple. Like, well, it's not going to change anything, so I'm not going to do it. You know, that's perfectly fine. All right. But when I distribute, I get x squared minus 5x is equal to 0. I want to write that as a function, so f of x is equal to x squared minus 5x. All right. Number 8's a little trickier because you have a fractional value in there. But we're still going to start it off the same way, except x is equal to 1/2, x is equal to x is equal to positive 6. All right. Now, ultimately, I mean, shortcuts aside, my whole objective here is to get from this step to this step. As in, I want the right-hand side of each equation to be equal to 0. So for a fractional value, the recommendation is to multiply both sides by whatever the denominator is to get rid of the denominator, because I don't want to have a fraction. So I'm going to multiply both sides by 2, and that's going to cancel the denominator here, leaving us with 2x is equal to 1. Then I can subtract the 1 from both sides and get 2x minus 1 is equal to 0. All right. For the x equals 6, same deal, except I don't have to worry about the fraction, so I could just subtract off the 6. But again, my ultimate objective here, at least for this part of the process, is to get 0 alone on one side of the equation. So this would be x minus 6 is equal to 0. Put it together, 2x minus 1, x minus 6, all equal to 0. But because I'm assuming a 1 unit slope of negative 1, I'm going to multiply both sides by negative 1. And again, I'm making that assumption because the parabola is opening downward, and I don't actually have the picture, so that I have no reasonable way of computing the 1 unit slope. So we just defaulted to a negative 1. All right. So I'm going to distribute 2x squared minus 12x minus 1x plus 6, all multiplied by negative 1, equal to 0. I could distribute now, but I could also combine like terms first. It really doesn't make a difference. You do it in either order. I'll distribute now. Negative 2x squared plus 12x plus 1x minus 6 equal to 0. My two like terms here. Negative 2x squared plus 13x minus 6 is equal to 0. Then I'm just going to rewrite it with an f of x. So f of x would be equal to negative 2x squared plus 13x minus 6. All right. One concerning aspect of this would be the fact that you really can't use the graphing calculator. Because if you're using a graphing calculator approach, remember, you need 3 points, with one of them being the vertex. I have 2 points. I have information about the vertex, but I don't know the coordinate value of the vertex. All right, so you're really kind of stuck with this approach. It's unfortunate, but it's kind of a trade-off for all the other instances where you could actually use a calculator. Here you're kind of stuck with one of the few instances where the calculator is not really going to be helpful.